Oh, look, this is Ido jumping. Ido, why don't you fly into space when your feet leave the ground? What pulls you back down? It's gravity, of course. But how can you show gravity to your students? How can you measure it? Let's consider one of the most famous scientists of all time,
Newton,
and his second law of motion and acceleration. All we need is the Labdisc motion sensor and
a ping pong.
Bluetooth wireless communication makes this a cable-free exercise. We will set up the Labdisc via the Globisens software. All we need is 3 simple steps. We'll open the setup screen, select the distance sensor, set it to measure at a 25 sample per second, and collect 1000 samples. That's it, we are ready to go. I'm going to hold the Labdisc 1 meter above the table, but first we need to open the cover for the distance sensor. I will start recording, and then Ido will drop the ball under the distance sensor. Immediately we see the data building with every jump shown in a peak of the graph. The ball's movement is represented by this graph of distance as a function of time. Let's use the markers and crop function to focus on the graph section showing the ball's jumps. We will first place 2 markers. Then use the crop function. Now we can see the ball's jumps. We can use the markers to focus our students' attention into a single ball jump. The free fall equations tells us that the ball's position is a second-degree function of time, or in other words, a parabola. Having selected the start and end point of one bounce, now I will press the quadratic regression function to get the parabola equation. With this equation, we can measure gravity. In 2 minutes of class time, with a simple piece of equipment like a ping pong ball, your students understand gravity. Got it?
Got it.